Hey friends, it's MoNaCo here. 9th homework video. Our third trend on the periodic table, we're going to talk about ionization energy today. You're going to understand how and why ionization energy changes as we go up and down a group and across a period. Ionization energy is this term that we use to describe how easy or hard it is to pull an electron away from an atom and turn it into an ion. So because each element has a different number of electrons, their ionization energies vary based upon their number of valence electrons and number of energy levels and the number of protons in the nucleus. This always comes back to that shielding effect. Probably the most important concept in this unit is that electron shielding occurs between the nucleus and the valence electrons, and it causes the atom to increase in size, reactivity, etc., or decrease depending on what situation and where we are on the periodic table. So the ionization energy is a definition. It's the amount of energy needed to remove the most loosely bound electron from an atom or an ion in the gas phase. Values for each element are listed on table S. It's kind of like when you're stingy with electrons, like the Scrooge. Okay? X being an element plus energy can be turned into an X positive ion and the electron itself. If you go across a period, ionization energy increases. Okay? As you go from left to right, it gets harder and harder to take an electron away from an atom. Why? Because there's an increase in the nuclear charge as you go from the left to the right, and shielding does not increase. So the amount of shielding doesn't increase, so the pull between the nucleus and the valence electrons, all the way out here, gets stronger as you go across a period. Since it's being held on harder as you go across that period, it's more energy it takes to take away that electron from the outside shell. Here's a great pattern. This is a periodic trend, starting with the first element, hydrogen, to helium. As you go from left to right, electron ionization energy increases. It jumps, boom, 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 and then when it gets to the next period, it drops down back again to a low state. So as you go across each period, ionization energy trends upwards. That's what you memorize. Okay. If you go down a group, ionization energy decreases. Reason, because there's an increased amount of shielding. Okay. Here's your Easter egg. On this picture, this main group elements, which element has the highest ionization energy and which element has the lowest ionization energy? In this picture, you decide which one's got the highest energy ionization and the lowest energy ionization. If you come to me and tell me what they are, Mr. MoNaCo, they're blah, 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 and blah, 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 and you're right, then I'll get you your bonus. Okay. So now you got to know how and why the ionization energy changes as we go down a group, and how and why it changes as we go across a period. It's all related to that shielding, and it's all within a trend. Got to know the trends. Okay? So thanks for your time. I know this is a short video. Enjoy!